Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Hi, my name is Timchik. I'm a tech manager here at the SEI. And we're here to talk about building software-intensive systems from a cybersecurity perspective. What we're thinking about and what we're concerned about is, how does someone attack my system? How do I defend against it? And one way of doing that from an architectural system engineering perspective is to think about threat modeling, right? Threat models are really important because they guide requirements, system design, operational choices to really identify those threats and then ultimately to create mitigations to it. With me today, I have two of my colleagues, Natasha Shevchenko and Alex Vesey. So welcome. And kind of how we start all of our podcasts is kind of tell us about yourselves and what brought you to the SEI and why do you like working here, right? So Alex, we'll start with you.
Sure. So out of college, I went and worked for a defense contractor for about 6 years. Really like the defense contracting space. We get to work on hard problems. And I mean, when it comes to hard problems in the realm of software engineering, I think the SEI gets to work on some of the more difficult ones. So that's why I ended up here.
Yeah, great. Natasha?
I first time get into SEI when I was a master degree student in CMU, Carnegie Mellon University, and I took some classes here. And I met a lot of very interesting people. And when in one point I was starting looking for a job, SEI was one of my first places to start look here. I really like working in SEI. One of the reasons because it's allowed me to find my interest and work on very hard problems to solve. And before coming to SEI, I worked in banking industry in railroad and communication. So I bring industry experience here, but I love
lots of different domains.
Like different domains, correct. And I hope to apply all of my previous knowledge for a couple of decades. And
we're glad we were your first choice, and you came. So Alex, you recently wrote a blog, right? Really talking about threat modeling and model-based system engineering, or MBSE. Can you tell us kind of what's that about and kind of where that, where it came from?
Sure. Yeah. So there has been a big push, especially across the government, but in industry as well, to start doing digital engineering, which is moving away from the traditional documents-based approach and couching more of the system design and information in digital models. And so a subset of that is model-based systems engineering, which is focused on managing the development of a system throughout its life cycle, right? And so marrying that with, as you mentioned before, the threat modeling, especially early in the systems development lifecycle, I think has major benefits for being able to build secure systems and systems that are secure by design.
Right. So, so there's a great plug for, we do have a conference event coming up called Secure by Design in August.
Yeah.
Right? But back to your point, there are 2 points there. One is, transitioning from a document-based to a model-based system engineering, right? What I like about that is you say it once but reference it often, right? And so, I can have different views of the data based on my engineering discipline or based on my what I need out of the requirements or the design, but it's all one set of truth. With that document-based, well, I never know which version, right? And so, you updated this version of that document, but those changes haven't been captured, or the related changes have not been captured as other document, right? So you always had the syncing problem.
Right.
Right. So I've always really liked the fact that the MBSE, the digital engineering approach, really solves that, assuming you have good configuration management, obviously.
Sure.
So Natasha, can you kind of tell us you've done this for a while. You've been model-based system engineering as well as threat modeling you actually have a couple older blogs from several years ago out, right? What's the current state of threat modeling in terms of system engineering?
So threat modeling is still lives mostly on the low level of design. So when design of a system already exists, and then engineers start to analyze it from security point of view and try to model there. There is attempts to move the threat modeling to the left, so-called. It means to start to work on that earlier, and there is a couple of articles about the inherited threats, which is coming from a business level that affect the system. You can't remove it, but the threat modeling as a methodology is still pretty much more art than engineering. There is no one single standard. There is a couple of methods, but they are mostly rely on engineers on their experience and expert judgment, exactly. And again, the level of quality of your analysis like that depends on this expert level.
Right. So what I find is there's now various attack frameworks, and there's other standards and examples of different methodologies that have been found in the wild in terms of attacking systems. You really start studying those things and being aware of the different ways in which your system can be, right? And that's really that cyber analyst type of role comes into play.
And they're mostly standalone. It means that the attack, it's one of the MITRE taxonomies on tactics on threats and attacks. There is another taxonomy that it's CAPAC. That is about the high level. Again, MITRE produce it. There is a connection secondary, but it exists in the form of leaks on the website, or it's best as a spreadsheet.
Right.
So they're not presenting the coherent one space on threats, threat types, methodology. It's treasure troves for analysts. They're true, but it's hard to use on a high level of architecture, for example, because they concentrated on specific tactics and specific implementation details of a system. So it's very hard to think about cybersecurity and specifically threats when you just planning your system or planning your infrastructure, when you don't know exactly details. But sometimes if you miss this and you start to think about something in detailed design, it's a little bit too late to fix this problem.
It's more expensive.
It's much more expensive and add to the life cycle
takes
and
more
development.
time and all those things.
Exactly. So there is a gaps in tools to bring these different frameworks together and make it available to architects, to software architects, to maybe even enterprise or domain level architects, so they can look in these taxonomies of threats and think how they apply to their system. If they have similar problems, similar vulnerabilities in just when they plan the systems,
right.
Their systems.
Although I still find it encouraging that those resources exist, right? And while it's still hard to take those and abstract out to the left, the fact that we're now thinking about it is still kind of revolutionary, right? Because 5-10 years ago, cybersecurity was really just very compliance-based, right? Mm-hmm. Here's the check my box, do these things, and there's also very much to the right? And if I find engineers versus cyber experts, they actually have very different vocabularies, right? Because they came from very different places, right? Software developers came from the engineering domain, and cyber analysts really came from system admin operational domain, right? And so getting that text, that vocabulary, and start transitioning it to engineering language, right? I think is just huge, because what we really need is software developers to think and understand that their decisions and implementations has consequences, right? But the sooner they know that, the sooner they start thinking about that, the sooner you actually have a secure system by design, not, hey, I checked the box, I built a moat around my system, and I hope I can defend it, right? And so it's a very different mentality.
Yes, and if we can bring it even earlier, when enterprise architects think about this system, and they should be able to think about on the level of a big piece of infrastructure. It's not just like computers and nets and the subnets. It's computer centers. It's data centers. It's secure enclaves that can
or large weapon systems.
Large
right?
weapon systems.
Department of Defense stuff, like weapon systems is a system that also has lots of support systems that support it. So it's this enterprise, right? It's not just a single element.
Yes. So most of the time, the enterprise architects, they know they need to think about security, but there is no methodology or ready ontology to express this concerns. Right. And if using specifically MBC, which is covering whole life cycle, to help to bridge these gaps, to go through the actual artificial borders that stand between the level of architecture, and they will. So all architects from enterprise to software can talk the same language and understand each other, and even pass to engineers the solutions they can implement. So this traceability from the very early stages of design of a system to implementation of a system, this gap actually we try to bring to close with work we're doing with Alex, and his Alex blogs actually talking about that, how to help, because sometimes addressing the threats of your system and then mapping it to the existing standards. I'll bring a role of standing and prove that what you're doing is it makes sense. It's not just in your head. There is industry supports you, and industries with the standards show you there is possible mitigation for that, or there is some security controls that you will be compliant with if you close this gap, if you mitigate this specific threat.
Right. So Alex, you're relatively new to some of these tools and techniques.
Sure.
You have great experience as a developer, and you've moved up to more systems engineering thinking of that nature. If I'm new, the audience, they come say, well, how do I get started down this path, right? What was your journey that kind of got you to where you are, where you're now writing blogs about threat modeling and MBSE?
Sure. So I think it kind of follows the progression that you had mentioned, where a lot of cyber analysts come from an operations or a developer background. And so you start with kind of the very detailed, maybe more narrow view of mitigating particular threats in, say, an operational system. And so there you're, again, looking at very specific, a solution architecture, something that's been implemented. And so if you start there with understanding how a particular threat is mitigated on a particular system, I think then you can start to transition your thinking to maybe more broadly of how does that, say, class of threats get mitigated, and ultimately as a software developer, what sort of patterns or architecture could I implement that might be able to eliminate, say, like a particular class of threat completely from my system. And so I would say that's my, idea of how you might go from, say, like a software developer, someone who's maybe not super threat conscious or isn't thinking about maybe the higher level like design implications of like a particular threat, to kind of having that broader view, I suppose.
Right. So I think most developers don't really understand or realize that they're implementing an architecture. Right. There's a lot of times they inherit architecture. For example, microservices is a well-known and well-used in modern technology, but that's actually an architectural pattern.
Right.
Right. That's not necessarily the right pattern for every solution. And sometimes developers just blindly use it because that's what everyone else is using.
Sure.
Right. And so when we talk about model-based system engineering and taking up a couple more levels of abstraction is what am I actually trying to build so I can pick the right patterns to find the right solution. Right.
Sure.
And I think once you start realizing that, that's probably when you probably start like, oh, there's more to this. Right.
Yeah. And Natasha mentioned earlier, there are inherited threats, right? That you just get because you pick, say, like a certain architecture, or even maybe just because you're engaged in like a certain type of business, right? So that's getting like pretty high level, to more of almost like a business strategy kind of level. But to your point about like the microservice architecture, there are certain threats resident in that architecture that just wouldn't be there if you, say, deployed like a monolithic application. So.
Right. Which is beneficial because if I pick a pattern, I should be able to figure out, well, what are the inherited risks or cyber threats to which I then need to mitigate.
Yeah.
Right. So there's benefits also of picking a pattern, because then people have already written research and there's literature out there that you can usually try to find to help guide you to go, okay, if I use this pattern, then I need to worry about these things. Right.
And that's also where getting systems engineers and architects to talk to each other can also help promote cost savings and mitigate risk at the same time. Because if you choose an architectural pattern that has fewer inherited threats for like your particular domain, then all of a sudden you don't have to implement a bunch of security controls on the back end because they're just simply not applicable.
Right. Forcing me to do the wrong solution to meet your need always costs more.
Right. And that's where you end up kind of implementing those security patches on the back end where it costs more and can limit like the system capabilities. Right.
So Natasha, in terms of we asked you kind of like what's the current state, right? It really is very immature. Right, in terms of threat modeling, data nature. Part of your work is unified architecture framework standards, right? And so I know I've worked with you in the past where we try to do threat modeling using UAF, and we really found it was missing some core elements. Can you talk about some of those core elements that you think that the current UAF standard is missing, and that we're working to try to actually improve to make it more useful from a cybersecurity perspective?
Yes. So UAF is the architecture framework, unified architecture framework, is and language that accompany it, built to describe the correct way of architecture. So how we need to build our system so it will perform according to requirements and so on and so forth. What it's missing is a vocabulary to describe the fault state of a system. What happened if my system is misbehaving? What happened if some actor will perform something that put my system in a fault state? So there is no lingo in UAF to describe it. So, and one of the first questions, main question when you do threat modeling and you ask it, what can go wrong with my system? what can go wrong in this specific component, or here when these two components interact with each other. So there is no way to describe it. You need to have extension to the standard to describe it. So this is what actually we did. We create a custom profile that extend UEF that allows you to describe a situation where my system can break in some way, can produce a fault result, or not produce result at all, for example, which will be failure of a system itself. So and this allow us to start this kind of analysis. So to describe the situation, to describe the potential actor who can do that. It's allowed to connect it to place in architecture where this fault can happen. Is it component? Is it interaction? Is it the process, like business process, that something goes wrong? So it's like starting point for analysis. Right. And then you can, as soon as you identify it, this is like first step, finding the threats, find it, who can do that, what effect of this threat, what happened, and or why we care about this specific threat. And then we can start thinking about next step. Okay, we have this vulnerability in a system, how we can fix it. And there, the next step is mitigation. UEF gives you the language to talk about mitigations, but
you need the others to be able to relate it to the actual threat that you're trying to mitigate.
Yes, yeah. But otherwise, they have a risk element, like a risk, but it's not enough.
It's not enough.
It's not enough. Risk, it's undeveloped in some way, especially for cybersecurity and threat analysis, undeveloped element. So we extended it so it will cover specific needs for cybersecurity analysis, specifically threat analysis.
So Alex, we keep using the word threat, right? And so people probably have different imaginations of what that might mean. In your mind, what is a threat from a systems engineering, architectural perspective?
Sure. So in the model, the threat, as we have defined it, is really a scenario that incorporates a couple of key elements that include an actor. So who's actually going to be carrying out, say, like the attack, the effect that threat is going to have, what is going to go wrong with your system, the objective that someone might be trying to achieve.
So why would they even want to do it?
Right. And then crucially, a separate but related element is the attack. So the specific way in which a threat actor would achieve their effect and their objective on the system. So the threat is kind of the combination of all of those, because you have to have both an actor that is like capable of doing a particular act to cause your fault state, as well as the vulnerability or the underlying weakness in your system that they can exploit. So it's a combination of kind of those three elements.
And then so we use the word actor, right? And so I think a lot of people who are in the start, they think about persistent threat or nation threat, right? That threat could actually be internal. It could be your developer, right? And their intent could just be laziness, right? And so it's just I didn't do a code review. I didn't run my static code analysis, right? So I have this weakness, right? And so I just want to kind of, for the audience, to understand, like, an actor can be anyone depending on what the system is that you're defining and the type of threats that you're perceived, right? And the other part is understanding what the impact of that threat is, right? That's really important if you're going to prioritize, because you can't mitigate everything, right? To truly mitigate 100% of a system, I basically just turn it off.
Sure.
Right? And so it becomes unusable. So there is always a balance between security mitigations and like usability.
Right.
Right.
And so that multiplicity of having, multiple different actors, like an insider threat or an advanced persistent threat that could cause a problem in your system is actually, I think, one of the maybe unique things about how we have integrated like our method into UAF. So a lot of other threat modeling methods will incorporate things like attack trees or kill chains, right? And those are good because it shows you like the end to end, like how an attacker goes from accessing your system all the way through causing an issue. However, in some instances, those attack trees or chains can be somewhat limited because it requires you to walk the entire sequence, right? However,
they also assume like you're at the solution base at this point, right? You kind of know what technology you're using.
Right.
Like you're at the implementation phase when you do that type of analysis usually, right?
Sure. But each step of the way, every way that a threat, say, leverages a particular vulnerability, it could be different actors along the way that cause or reveal those different vulnerabilities, right? And so being able to think about the individual pieces of the chain and not have to lay it all out to start, I think is somewhat helpful because it doesn't matter if how a system got into that fault state, just that it got into that fault state. And that's what we're trying to avoid.
Right. So, Natasha, I talked about the secure software by design, which is more focused on software developers and how can they start thinking about security and like using good engineering techniques to do that, right? You have another event coming up is like MBSE in practice, right? It's also, I think, in August. So what's that focus? Like, how is that kind of scratching the itch of these things that we've talked about?
So MBSE pop up to the top of in the industry like during the last 5 or 6 years approximately, and it's combined the multiple methodologies, multidisciplinary thing, and learning MBSE methods and practices. It's pretty sharp, pretty steep learning curve, and I think very often people who see it for the first time, they don't know where to start, how it can be helpful for them because it's so vast, and different tools involved, modeling languages involved, some domain-specific extensions to the languages, to the methodology involved, and a lot of theoretical work going around, like books and articles and so on. So the engineers and practitioners actually have the problem. They need something concrete to take in and use it right now.
To get beyond the theoretical and like, how do you do this in practice?
Yes,
like, what are the best, things you've learned? What are practical tools and techniques or tricks of the trade? And
it should not be vendor specific. It should not be actually. It's not necessary to be domain specific. Something for like automotive company or defense or something. There is a common thing. There is a common practices that MBSE practitioners can use right now to solve very specific problem they have with their companies. And I hope that we get variety of speakers that will cover all aspects of adopting MBSE, using MBSE, extending the practices, and bring the case studies, how they use it. I know we will have absolutely awesome key speaker I won't say it here.
Yeah.
I'm absolutely happy we get him on our side.
So really, it's trying to create a forum to bring people who are actually practicing it, not to let's stop talking about the theoretical stuff. Like, how do you actually do it? Let's come together and like share those best practices.
Yes, and they use it not only on examples or prototypes, but they use it on real systems, and it worked. And they bring this experience to share with fellow BC practitioners.
Great. I look forward to attending that event. So what's next? So what are you guys working on that might bring you back for a future podcast? So Alex, what are you working on?
Yeah. So like in this blog, talked a lot about integrating like CAPEC. However, I think there's a lot more work to be done in integrating other frameworks, other taxonomies to give cyber analysts, threat modelers a larger library of kind of ready to go threats and mitigations so that, you can take the most advantage of MBSE and the MBSE tools to, kind of rapidly model and mitigate threats across not just software in general, but even some of the more specific domains.
Okay, I look forward to it. Natasha, what's going to bring you back here?
I think that what would be interesting to talk about is actually how to model comprehensive cybersecurity architecture on a high level, and make specific and talk about specific techniques, how the architects can use the MBC, can use specifically UEF to model not only the correct final architecture of the system, but start to think about the fault states, and so they can architect in the solutions for the security for the system. Because you thinking only about happy cases won't help. You need to think about the worst cases, unexpected cases, how your system can be abused.
Right.
And it's
that's the harder part. Like the happy path is always easy, right? Because that's the ideal path. Right. I can't imagine why anyone would push that button, right, or do it that way. And well, they will because they can.
Yes, and these questions should be answered as early as possible.
Right, and we can mitigate it in the most cost-effective and resource way, right?
Yeah, I would probably it's known thing is that worse problems is that problems introduced in requirements and architecture stage. They're most expensive to fix.
Because they're the ones you don't find until you're in the operational phase. Because you've gone through the entire engineering life cycle and the money's gone, the schedule's gone, but you have this defect.
Yeah, and very often, too often, it's only when the system alive you find this error.
Right.
You find
that soon. And that's really what this technique's all about, right? So thank you for joining us. Appreciate it. It's a great talk. For those who join us, thank you for listening. We will provide links to the material that we've referenced today in the transcript, so you can find that material. The SEI Podcast Series is available in all the places you can find podcasts: Applecast, SoundCloud, Spotify, and the SEI's YouTube channel. As always, if you have any questions, you don't hesitate to email us at info@sei.cmu.edu. So thank you for joining us.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, TuneIn Radio, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.